Okay, the second method of solving a system of equation is the substitution method. Basic premise here is we are going to solve for one variable, plug an expression, or substitute it into the other equation, and thereby eliminate one variable so we can actually solve for one, because we can't solve for x and y at the same time. Just to give you a few basic steps. Step one, we're going to solve one equation for one variable. In this one, I'm picking our first equation to solve for one variable. Because there's a negative 1y, I'm choosing this because it'll be a little bit easier. Won't have to deal with fractions, but you can essentially solve for whatever variable you want. Easiest choice if you have a 1 for a coefficient. So I'm going to solve for y, giving me negative y equals negative 2x plus 6, and I'm going to divide by negative 1 all three terms, giving me a y equals, dividing by negative 1 for all of these, negative 2 divided by negative 1, positive 2x, and minus 6. Be careful with your signs. Okay, I've successfully solved the first equation for y. Step 2, substitute that expression into the other equation. So I've now rewritten my second equation over here, and I'm going to take that equation, but instead of putting y, I'm going to put my new expression that I have for y when I get over here to this y. So I'm going to rewrite 12x plus 4 times y equals negative 4. But instead of actually putting y, I'm going to put 2x minus 6. Okay, I'm substituting this right in there. From here, I just go ahead and solve that. If you notice, I now have two x terms, and I have no y in my equation. That's exactly what I wanted. So I have 12x plus, I'm distributing 8x minus 4 times 6, 24 equals a negative 4. I can combine my like terms, giving me 20x minus 24 equals a negative 4. Add the 24, so 20x equals 20, giving me x equals 1 when I divide. So I've now been able to solve the second equation, and look, I actually have half my answer. Remember, your answer is going to be to any system of equation. Solution is going to be a coordinate point, an x and a y value. So I now have 1, my first part of my coordinate point. The last thing we're going to do, step 3, is we're going to plug our first answer, that's our x equals 1, into either equation to solve for the other variable. Totally does not matter at this point. Okay, my personal preference is I'm actually going to go right back to this equation that I had when I solved for one variable, because if you notice, we actually have it already solved for y, and that's what I'm looking for. So I can go ahead and say y equals 2 times x, but remember x is 1. Plug in the 1, giving me 2 minus 6, giving me y equals a negative 4 for my second answer. So of course we're going to put that in our coordinate point. 1, negative 4 is our solution to this system of equations. Okay, if you watched the graphing video, I did the exact same problem. If you did not watch it, here it is, the two lines graphed, and essentially 1, negative 4 is the point of intersection of the two lines. So graphically, we're finding the point of intersection of two lines on a coordinate graph. Okay, but using the substitution method, we can go ahead and do it without graphing anything.